It's Wednesday, April 29th, and today on the live stream, I'll be looking at getting persistent volumes set up on our Kubernetes cluster. It's Wednesday, April 29th, and welcome to the live stream on Adventures in the Cloud, where we explore new and interesting concepts, tools, and ideas. Where else but in the cloud? My name is Yufeng, and I'm delighted today, as part of our Machine Learning in Production series, to be looking at how we can attach our GCE persistent disk to Kubernetes. So a little bit more about kind of this series, Machine Learning in Production. It's going to be a series of videos providing a behind-the-scenes look at the process of building out data and machine learning infrastructure. Along the way, we'll kind of encounter everything from data storage, web development, networking, security, scalability, and of course, machine learning. So let's dive into today's topic, this notion of how we can attach a persistent disk, or in layman's terms, in some ways, just a hard drive, right? But in a data center scale, to our Kubernetes cluster to allow things to connect into some block of data that we have. And what's nice here is that because persistent disks can be kind of moved around very easily as a giant block, you can attach it to, say, your compute engine instance, as we did in a previous episode, and load up data on it. We can work on the disk directly. We can manipulate it the same way we would access the file system in any other environment. This brings a certain degree of simplicity to using this kind of workflow, right? You can put data in kind of scalable databases, of course, right? In situations where you need a database, please use a database. In situations where you might put things in some kind of blob store or distributed file storage system, there are situations that are appropriate for that as well, but it comes with the overhead of needing to interact, usually via the API or via a client library. You have to code something up in order to be able to programmatically access that system. What's nice about using a persistent disk is that you can access it like a file system, because it is your file system, right? So you can attach it to a compute engine or VM, attach it to your virtual machine, and just access it as a disk. You mount it, and then you can just read and write straight from it. Do whatever you need to do. Download your data set, move some data over, throw it onto the disk, write whatever scripts you need, just drop it all in there. And then when you're ready, you can then unmount that disk. And now the idea is we got to do that final step and put it onto our Kubernetes cluster. Because doing all of that, what I just described, with the disk mounted to your Kubernetes cluster is certainly possible, but then you've just added all this overhead for yourself of having to basically tunnel through your Kubernetes cluster, find the right pod, et cetera, et cetera. And in particular, what we're trying to do is we want this persistent disk to be accessible from all the nodes on your Kubernetes cluster. And so for a little bit of background, if you're not as familiar with Kubernetes, it's a system for orchestrating your containers, typically Docker containers. And so containers make pods, pods live on nodes, and nodes are just virtual machines that are configured together into one network, basically, in this case. And so you can have multiple pods per node. And if we want to attach this persistent disk to your cluster as a whole, that means we will be able to read from this disk all together, which is really exciting. And just pausing here to check out the live stream, or the live chat, I should say. Shout outs to Lynn and Grania and Deirdre and Mert and Rajan. Thanks for tuning in. Really excited to see you all. It's going to be an exciting one. We've been working with persistent disks on and off throughout the various live streams that we've done. And so it'll be cool to kind of take it a step further here and hopefully move away from having to administrate and deal with the mounting process manually, which is kind of part of the hurdles that I was running into before, was how do we actually deal with this directly? And so So yeah, and Mark Eden saying hi from Palo Alto. Hey Mark, thanks for tuning in over, I guess it's noon over there. And make sure I've got space on the disk. That's right. Sure, I can make it a little bit louder here. We're gonna try to make sure you can hear me okay. That's important. And let's see, let's go over to our console. And one change that I've made since our kind of last time that we streamed, that we chatted, was I've replicated this project into our original project into a new project. Okay. And the reason for this is I wanted to be able to basically develop in kind of a, how do we say it, slightly, TikTok pattern almost, right? Where I'm a little bit, not TikTok the app, but like Intel's like release cycle tick and talk, where I'll basically develop a little bit ahead of time before the live stream so that I can try some things out without like polluting the code base that I'm using in the live stream, and make sure things are all generally set up. And so, but I didn't want to develop ahead and then just show you the code I wrote. I do want to try to write it, but at least we'll have something of a fallback. So if that all sounds good, let's head on over to our Kubernetes engine and clusters view. And so you'll see I've rerun a lot of the stuff, and this was actually a really useful exercise in terms of making sure that I had all the commands I needed to run kind of stored in this README. And I also discovered the preview button in the Markdown kind of format in VS Code, which is kind of nice. And so now I can kind of like have things nice and easier to access. So I appreciated that. How do I close this out though? Oh yes, the X, of course. Let me move this down a bit so folks can see it all. And so what I've done is I've made kind of side-by-side folder structuring. Let me resize this window so that everything is showing up properly. And I got this long notes doc now, much of which is now transcribed over to this README so that we can all kind of work in one space. And let's take a look at what GCP has to say about Kubernetes, and in particular about the topic of persistent volumes. So one of the things about persistent volumes is, and I'm kind of using these terms a little bit too interchangeably, so let me clarify. Persistent volumes is the generic kind of type or term that Kubernetes uses to describe the disks that are attached to the cluster. Okay, and so you can back a persistent volume with a number of different storage formats. Because Kubernetes is open source, it means it can run in other cloud environments. Or even local environments, right? You might be on your local data center and you can have a persistent volume configured that is your own equivalent of a persistent disk or other kind of hard drive array. And so, this doc kind of describes this idea of what is a persistent volume resource, which is how things are available in Kubernetes. And then this notion of a persistent volume claim, which is something we need to build kind of on top of that. And I had a sketch written down. Let me grab that. I was trying to get a better understanding of all of this, and basically what I concluded was that given a persistent volume, PV, with the persistent disk in it, basically, that wrapper was then pointing to or pointed to by a persistent volume claim. So that's around that, which then is looked at from the Kubernetes pod. So this is a lot of text, and I want to kind of show some of what the journey looked like in order to get Kubernetes persistent volumes kind of working in terms of understanding what is happening under the hood and what you needed to make this configuration work. And specifically in this current project, we have this cluster, and so just for completeness, I want to show you all what we have as our starting point, right? So what I've done after a considerable amount of searching around is I've copied, I thought I copied, the disk, here we are, the disk from the other project over. So it's the same disk, and as Rajan made sure to tell us here, we got to make sure it's big enough. So I allocated the same size disk in the same zone and copied it over, and actually named it the same name as well, but it's a different project now. And our Kubernetes cluster has, let me switch back to this tab. We have our Kubernetes cluster, and I'm going to connect to it. And so that was one of the useful things. So I've had to really figure out how to swap between two projects now, which is a useful kind of piece of knowledge to have. And one of the notes I made, assuming I didn't lose it, which is always possible, let's see here. It was one of the gcloud container commands. And it might not be in this README, it might be in the other README. So this is what I get for having multiple READMEs popping around. So this is this project, and the one that we'll be working off of today is in here. I don't think gcloud container get credentials, yes. So this will help configure kubectl. So right now my kubectl, well, first let's change into the correct directory for what we're going to be working on today. We're going to add Kubernetes to what I've termed the master branch, which is mainly just for today. So we'll kind of alternate between these two. And in here, I already have our Python environment set up. kubectl, what is it? Config auth, something like that. I can never remember the exact. That's not quite right. But the bottom line being that I need to configure CloudML. What did I have? What we'll do is we'll copy the README. Yes, this is the plan here. We'll take what I was working on before. That's this README file. I'm going to copy that file, and we're going to drop it into this one because the current README here is pretty much blank. I'm going to delete that, paste that back in from the other place, reopen it. So now we have like a clean everything in the same folder, because there was some risk that I'd be in the README of one repo while working on the other, which is not going to end well, right? So this repo, let's switch our project over. And so what I'm realizing, what I realized is I kind of need to be have these scripts ready to go so that I can run this and have all of the project names, regions, and all the config defaults basically set correctly. I'm already in the folder, and this is kind of to build and deploy to cloud run. So these are commands from the future that we'll use down the road. But for today, we're going to take notes on persistent volumes in GKE. All right, so now when I run kubectl get pods, we should get this pod, right? And then, and more notably, when I run kubectl get services, let me make this a little bit bigger. I should have this external IP, which we can see here. This was the old one. This is, yeah, so this is the same as what I was playing with earlier. Okay, so now we have what should not be able to connect out to the persistent disk, right? So if I do this and I hit submit, it won't be able to find it, and we can see what the error was for that with our usual kind of pod tracing approach, where we have our pod. We'll set the environment variable, paste that there, and we'll see that the path doesn't exist, right? Our old code, what it did was it tries to look for that mounted disk, and of course we haven't configured that, because in this project what we have is a deployment that doesn't have anything special attached to it. And so let's talk about what we need to put in here, right? So it talks a lot about a couple of different options that we have with persistent volumes. There are really extensive ones that have a lot of information that we're going to pass on. Thankfully, we don't actually need to write all of this ourselves. And once I kind of found this doc, I then went onwards to kind of search the term persistent volumes at a more general level. Persistent volume. So that's the tab that we have. And then we can kind of start looking at some of the examples in Kubernetes. And the other thing we can look for is, I thought it was in this page, but I guess not. I'll search, try a different term here. Kubernetes persistent volume read many, right? We want to set it up so that you can have multiple readers on the same persistent disk. I don't want to replicate this block of image data from our open images data set. And so let's see, configure a pod. So this is from kubernetes.io documentation. Using persistent disks with multiple readers. See, I knew I had seen it somewhere in here. And so this is a useful read through if you're interested in kind of learning more about persistent volumes in general. It is a very in-depth coverage of the topic, and there's lots of kind of subtleties to it. And let's see, I believe that at some point it does kind of, it talks about that, as I mentioned, there's lots of different ways to back a persistent volume. GCE persistent disk is certainly one of them, but there's lots of other choices across many, many cloud options. And so creating a persistent volume is really just a specification of what kind of, it's just the disk. It's a thin wrapper around the persistent disk itself. And you can see what I'm using as a persistent disk YAML file here. We have a persistent volume with a name, and the top half here is the relevant bit. The name of our disk, right, was Open Images Disk 1. And so that's reflected here in the persistent disk name. And then what we want to do is include extension, because the file type is ext4. We have to make sure we include this read-only true flag. That's super important because we want to have it be read-only many, and that's reflected here under access modes. So there's a couple of different pieces in play here that make it slightly different from a normal persistent disk, a normal one being one that you can read and write to. I want that one that you can only read to, and so this will allow it to be read from many pods. Now, a claim ref or a claim reference is going to be how we refer, how a future persistent volume claim will refer to this persistent volume. And so this is a name, if my understanding is correct, that we are setting here. We can choose what to call it. And then down below, we simultaneously create the persistent volume claim and give it the same name, right? Or rather, I guess I got it reversed. This is the claim that refers to this disk. Here's the claim being created and a name being given. And again, we have to write read-only many and the size. Again, this is the claim. This is the request for storage size, and this is the statement of the capacity of the storage size. So they don't have to match, but this one needs to be at no larger than what the disk claims to have storage for. So 4,000 gigabytes, hopefully that'll serve us well. And this is where things got a little bit haywire. Because in these guides, when they talk about using multiple readers, right, it starts out by talking about you must format your disk. And I was like, do I have to format my disk again? Because I spent all that time downloading the data. So I was like, I was really hoping to get away with not doing that. And if I had to, what I would have probably done is created a new persistent disk, formatted it, mounted it onto the same VM I had before. So now I have two persistent disks side by side. and then read from one and just drop it into the other after formatting it. But since I'd done that already, I'd already done the formatting and turning it into ext4 when I created the persistent disk. My hope was that I wouldn't have to, and I was luckily right in that consideration. So and then it says format it, populate it with data. We did that before. Unmount and detach the disk. Super important. I forgot to unmount the disk the first time. That was a fun experience. Not the worst though. You know, you just get an error. You're like, oh, I don't know what's going on, and you realize, okay, I need to unmount the disk. I guess I couldn't get away with it being mounted to a virtual machine, which I was kind of sad about because that meant that I couldn't access it from the notebook anymore. But I was like, all right. And could I create a snapshot as a backup? Yes. Good call, Rajan. So how did I make this other persistent disk? It is exactly by doing that. I'll show that. I created a snapshot, and that's how I created this other disk in the first place. So the original disk lives in a project called CloudML Demo. And you can see that this is the familiar view that we had. And I don't think they show the snapshots here, but this is the button to create a snapshot. And you can see my snapshots in this project here, if it will load. This is my snapshot, and that was created a while ago. I decided, you know, it'd probably be good to create a snapshot. So I created that snapshot and then made this other disk in this other project out of that snapshot. So that's a great call, right, Rajan? And we'll... yeah, and in terms of how did I do that, it's probably, you know, in case you're trying to do something like that, it's a little bit trickier than it you would hope it would be, right? Given that I have access to both these projects, why can't I see both snapshots? And I can't, is the problem. I can see this snapshot. So I say snapshots, and you notice I pass the project name here. And if I do this, you'll notice that there's nothing listed, 0 items. So the only way to make a snapshot in this project, which doesn't itself have a snapshot, the snapshot is elsewhere, is you'll notice there's this -- URI value. And so we can paste that in, grab the URI, this link that encodes the project name in it, and then we can pass that in the disk create command when we run gcloud compute disks create. And we give it a name, and we give it a zone, give it a size, and then source snapshot, which normally you can just say the name of it, will also accept that URI, which encodes the project name. And so that's the secret key that after some digging I figured out. So if you ever end up in a situation where you need to use the snapshot image from one project somewhere else, use the URI, assuming that you have permissions and all that stuff. So do the IAM permissioning stuff, but like oftentimes even after you do that, the instructions weren't super clear about like, how do I see it? How do I have access to it? With images, it's more straightforward. There's actually a flag, say like, you know, image from project. You can say what project it's from. But with snapshots, there's no such flag. So it makes it a little bit trickier. So hopefully that answers that question. And let's see. Where was I? We have the snapshot. We have our disk. Right. So now we should be ready to create our persistent volume and volume claim. So you can see here, this is basically where I got the persistent volume claim and persistent volume doc from. So this is read-only persistent disk.yaml, which is basically exactly what we want. And this will look almost identical to what we had in the file, right? So you see the three dashes. We have persistent volume claim, and one of the differences is instead of 10 GI, I wrote 4000 GB. I want to say, did I write GB or GI? Just G. So I basically went off of whatever the UI in here showed. I've seen it both ways. I'm honestly not sure which one it's supposed to be, quote unquote. Like, I understand the difference and all, but I don't know which one I have, so to speak. And so let's create that and show that hopefully it'll work. because there's no promises that it will actually work. So that's kubectl apply-f and then this file name. So let's make sure we are in the right folder. So I see our open images persistent disk.yaml. So kubectl apply-f this. I'm going to copy that also. Throw that in our README. It's worth noting. Create persistent volume and claim. So after this is created, right, we then it talks about then using it in a pod. And I read through this and it's like, okay, yeah, I can see how, you know, we have this volumes that points to the persistent volume claim. But the trouble was that these instructions will create a new pod. And as someone who was relatively new to Kubernetes, I didn't actually know how to include it in the pods that we were already creating. So you can see here in the Kubernetes documentation, it says we can create our persistent volume, and you can we can get information about it. That's probably worth noting as well. Let's do that. And what did we call our persistent volume? The name value at the top. So let's see that, have a look-see. So here we have our persistent volume, capacity 4 terabytes, read modes, read only many, hopefully is what I'm gonna guess that's what it means. Reclaim status bound, default / open images persistent volume claim. And then it gives instructions on making the claim itself, which we kind of put in the same file. And so we can get PV again, but this time pointing at the persistent volume claim, which has the -pv at the end of it. -claim. What did I do wrong? Open images PV claim. I guess it's all tied together. So this doesn't quite work yet. Let's see if we can figure out why. Persistent volume, and then it looks at the claim. And you can see here it says claim is that. So let's look at what was printed out earlier. Here. Maybe I need the default / in front of it from the open images. Oh, I wrote it wrong. Did I? No, I wrote it right. Open images PV -claim. So let's try this name. There's no need to specify the resource type as a separate argument when passing arguments in resource / name form instead of, not sure which piece they're saying I did too many of. Is it PVC? Is that a typo in the, yeah, I thought it should be different. Ah, very good. So I think you just found a typo. Nope, you didn't find a typo. I just can't read. It is PVC. Thank you very much, Mert. Huge save there. I was like, why would the same command do that? So it doesn't. 2 different commands, 2 different outcomes. Very good, very good. All right, so then it's, again, even these instructions talk about the next step is to create a pod that uses your persistent claim as a volume. And it's like, that's great, but I don't want to create a pod, because you see here, it's just like apply, and it's just a pod YAML, but I'm not creating pods one by one. You have to do a get PVC. Yes, we have to use PVC. Oh, wow. VMware helping out. I was actually on some of the VMware docs about this to help me out. So thank you for that. That was very useful stuff on there. The main note I have for a lot of these kind of using PVCs in a pod that I eventually came to an understanding around was, yes, I don't have a YAML that specifically describes a single pod, but I sort of do. And where does it live? It lives in the deployment.yaml is basically what I realized after a while. so if we look at the previous version, this is the YAML that's deployed right now, okay? And we can see that it is just our standard deployment. It's got a name, it's got a spec, and it's got these containers. And I don't entirely remember where I saw it, but basically at some point in time, let me see if I can split screen this for us. And I'm going to close this, well, not that one, close this one, and push, let's see, how do I get that to show up in both? All right. So now it's a mess because it's super wide and we don't have that much window width. I'm going to make that big, make this do that. Sort of like that. Okay. What we needed to change, all right, so I'm going to put these side by side. This is all the same. All the spec is the same. All the metadata is the same. Let's scroll down to try to match it up. The spec, this part remains, okay? That's right here. Okay. And what I've added above and below it, and the ordering is you know, kind of arbitrary, is that at the same level as containers, we needed to add volumes. And so that's where OpenImages PV volume sits. Sorry, that's just the name. The volume that you can give it a name, I just put volumes because it was under volumes. And then this is where you state the name of that claim. You can see down below in our two commands that we ran, right? Our PVC is OpenImages PV claim. And so that's the claim name right here. And then inside of containers, so notice the alignment of the tab of volume mounts. This is inside of the container. We need to give a name. This is the same name as what was used up here, right? So you can see VS Code doing that dual highlighting of matching text. And I don't need to supply the OpenImages -pv -claim value anymore because, not claim, the OpenImages, which one was it? Yes, just OpenImages PV, that was the one that worked, because it's been wrapped inside of the claim. So it knows where to look. The pod only needs to refer to the claim because the claim is referring to the persistent volume, which is referring to the persistent disk. So it's this chain that is arguably a little bit tricky to keep track of, honestly, but so it goes, I suppose. So inside the spec for our pod, we have volumes and containers. And the volumes descriptor talks about what persistent claim, volume claim to put in, and then containers, you still have to point to that volume. And the key addition that this gives us is the mount path, right? For those who were there during the live stream, I know Rajan was there. When we first started mounting persistent disks to the Compute Engine VM, I went through all sorts of pain to figure out how to mount a persistent disk properly. It was my lack of, you know, I don't know, deep Linux knowledge, I guess. And so now what I'm doing is I'm mounting it to the same path that we ended up using before. So I could just lift the code from before and shove it into the app code and it would work, was the thinking. And so that's what we've basically done here. Let's see, I've gotten the persistent volume, I've made the PVC. I think we might be ready to push a new version of this. So the current version of our cluster, let's go over to GCR and see what version I'm up to. So yeah, I just pushed a single version over with this no persistent disk YAML. So if we take all of these kind of changes in the spec, and so one thing I'll point out, just to further drive the point home here, this is almost the same as the deployments.yaml, right? But it's being called pv-pod, and that brought some confusion. If I put this like here-ish, and I close, well, we'll look at this one first, and you'll notice that it's very similar to a, let's see here. It's very similar to a deployment file, but what was frustrating was that it was called kind::pod, and I was like, I don't have a kind::pod. But everything else ended up basically being the same, right? In this spec for this pod down here, you see volumes and containers. And this is the volumes part, and then inside of containers, there's mounts, which is the same setup as we have in here, right? We have volume mounts, and you could honestly swap these. Right? I could put this volumes bit down below. It doesn't have to be kind of declared above the way you would with like say Python, where you have to declare the function first, only then later can you call it, things like that. So with that all done, let's push it. kubectl apply -f, if I can type it. Wow. Deployment.yaml. Let's do it, and let's try to get things working here. So it says it's configured. We'll do the usual kind of sequence of commands that I like to run in order to check in on our deployment. Also, if anybody has a better way to do this other than the terrible workflow that I have, well, I mean, it's not terrible. It's just, I suspect it could be better. Because what I do is I get the pod names, and it hates me because, of course, I didn't actually do the right workflow. We have to actually build our container. So that deployment pointed to v2, and v2 does not exist. So good job, me. So let's see. Let's say this is build and deploy to GKE. So we want to build, deploy, update, deployment. This is more of a reminder to myself before running this next one. And we're going to run that. And then we can do get pods. We can run, we want to export pod. So one of the things that would be really cool to automate, and I think I could probably sort out how to do that, is automate the fetching and setting of this pod environment variable that we get back from running get pods. Let me set the deployment again. Oh, right, it's unchanged. So in theory, it should just fix itself, which is always a fun exercise, right? Because it's already on this image pull back off thing. Whoa, that's not what I expected it to do. So what that means is it's already kind of saying, hey, I can't find this pod. So you can see here when I run describe, oh, it's catching up already. So you can see in the errors, failed to pull image right here, :v2. And I've had situations where I've mistyped the project name, like this string here, or in this case, this doesn't exist right now, this tag, so it says manifest not found. So the error image pull, and then it tries to do back off, and it tries again, and eventually it shows up luckily, so successfully pulled the image. And so that puts us in a good position to do logs-f, and we can see that the cluster is booted. So now let's go over to our browser, and I'm going to leave this kind of underneath so we can see the output as it goes along. One of these tabs was our Kubernetes server. So here's our service again. So this time, we should be able to get a little bit closer. It's still going to be an interesting error, though. I'll say this much. The hint here is that our Firestore data that we have is not in this project. It's in the other project. And so what we're doing in this code is we're taking this file name and doing some lookups in Firestore. So it's still going to yell at us, I bet. And if it doesn't, it would be really confusing. All right, so there's something interesting happening here too, where now that I think about it, because I uploaded the service account key, it is actually doing a cross-project read of the Firestore database. So this is an interesting example where I am effectively migrating. This is okay. I'm inadvertently giving an example of how to migrate a project from one project to another. Migrate your kind of service from one project to another project, right? I've migrated the Kubernetes service at this point, but the backing storage of Firestore is still on the other side, and the prediction that we're getting out of here is also coming from the old quote-unquote service rather than the new one, which is quite remarkable. So if I scroll down, we can grab an image that we've never seen on this live stream ever before. Here's our world premiere of this image. I have no idea what it's going to be. I just scrolled down and I copied one, and it's going to be another bell coat. They really like these bell coats. And I have a wave from Gabe. Hi, Gabe. Thanks for joining. Great to have you on. And I think that pretty much is most of the way there, right, in terms of getting our original task in place, getting our persistent disk in place. I should say, point out what modifications we may have made to the application, because I kind of skipped around some of that. So the code itself is still referring to the old project, which is why it's kind of hilarious, right? All the API calls are calling the other project. And so, yeah, I have some sorting out to do and thinking about how I want to proceed with all of this. Do I want to continue really running two code bases in, one step behind lockstep, or do I want to get fancy with Git and basically, develop ahead, play around with things, then reset back to an old branch or an old commit for the live stream to show something. But I'm concerned that my Git foo isn't strong enough to pull that off, which is partly why I decided to go with the two separate paths in the first place, was in hopes that it would be a simpler solution. But, simpler is always a bit of a stretch. So let's see. This is the function I have for opening the images in in a persistent disk. And concretely, you see what we did was we did os.walk on this hard-coded path, which is the same path as what is in the YAML file that we use to configure the deployment, right? That's where we specified where the mount point should be. And so if you'll recall back in that image, that disk, we have kind of this train images and test images and validate images. So right now we're only pulling from train images, but that will change down the road. But this gets us to a good kind of spot to then, it can read from that, return it, and you can see here we can set up this path, using the path library, thanks to my colleague Chris Wilcox, being on the air during that particular live stream. And then we were able to, we can upload it to the bucket, which we also have read access to. So we've really, it's actually quite interesting. We've separated concerns of the service that is running and doing all the work and the actual kind of managed services in a separate project. So you can imagine an environment where on a team of developers, right? I'm playing both sides here, but you can imagine one group, which was past me, is managing a service that, a bunch of services. They're managing the AI platform stuff, they're managing cloud storage stuff, they're managing the Firebase stuff, and they could all be different teams too, and possibly different projects, as long as you threw all their service account keys into this image or into this container. Then you can have present me in this project working on setting up Kubernetes, setting up this web service that can call all of these backend systems transparently without having to deal with any sort of per project permissioning and stepping on toes issues. I could, in this project, store some stuff into cloud storage and not have to worry so much about keys and auth and stuff, because it's kind of my local environment. And so now it puts us in a situation where we are doing explicit permissioning across services. So that's an interesting thing to kind of encounter. In terms of what is ahead, we're going to be working on getting PubSub better. If you remember, last time I tried to PubSub, you can't only PubSub once. Last time I tried PubSub, I basically wanted to use the data flow templates to move the GCS cloud storage triggers into BigQuery, and failed, for lack of a better term. And what I'm realizing now is that I have a couple of other options. I could incorporate a push queue into this service, right? I could have an endpoint that receives notifications from PubSub and says, hey, a new file was dropped in here. What do you want to do? And since I already have a Kubernetes cluster, maybe I should keep using it. So that's one design approach. The other path I can take is to say, okay, I've gone through all of this work to basically use Kubernetes to put a wrapper around this big data set, right? This persistent disk at this point is really all I'm doing. I'm kind of reading from Firestore and stuff, but at the end of the day, all I'm really doing is getting the image from the persistent disk, popping it up to cloud storage, and displaying it on the website. So there's the web component too. And that piece doesn't have to, quote unquote, be in this Kubernetes service. I could abstract that out and have it be separated and arguably put on something like Cloud Run, where it originated from. That's the irony of it, right? Is that I might be in a position where I'm going to end up going into Cloud Run and then coming back out, going from Cloud Run to Kubernetes and back again. I could write a book about that. There and back again, a journey from Cloud Run and to Kubernetes and back. But basically, I want to go and add these kind of things to respond to cloud storage triggers. And I suspect, in the designs that I've sketched out so far, that I'll be using PubSub a lot more, really. Because, I can show you this crazy image that I've got going on here. It's a lot of things, and I'll probably turn this into something more readable, like a slide or something, so that you can kind of see the more details around it. But basically, the additional steps we have is we want live images to periodically trigger a batch update of some kind of training job, right? So at the end of the road, the next checkpoint essentially is to have a machine learning training job that can do updating of a ML model on a chunk of data. So imagine a situation where you're getting images being streamed in over time, right? So I would automate some of this where the images would just spew out maybe once a minute or something like that. And then Firestore would be counting them, cloud storage would be receiving them, and I would be annotating it in BigQuery. And you could do pretty easily a query, like a timed query, every once in a while run this job, do a query, see how many new images have come in since the last timestamp, and then figure out and basically get the list of images that you want. So you could do the sort of thing where you say, every 500 images, I want to trigger a new training job to kick off. And so you can imagine all of that relaying back and forth of saying, Firestore can trigger to either Cloud Run or a GKE endpoint and listen for the next data set being ready, reads from BigQuery, see how that's doing, then kicks off a training job. The training job can have callbacks to update the training progress, because at the end of the day, we also want to be able to visualize this progress on a web front end, but much better looking than what we have so far, I assure you. But right now it's looking a little bit scrappy. Also, if people have votes on what web framework to use, if any, maybe it should just be vanilla JavaScript and HTML. Please let me know what you'd like to see me try to pick up on the live stream and use. And then the training job, right, will finish training and deploy a exported train model into cloud storage, upon which that can trigger a PubSub message to take some further action, like deploying that model into production. And so there's going to be a lot of PubSub messages flying around. So the plan is to create some kind of more generic home for PubSub messages to kind of be responded to, right? And it would ideally be something that can be fairly responsive and kind of scale up and down, importantly. And so I'm not sure if doing more stuff in the Kubernetes cluster is the best move unless I improve my kind of workflow, right? Right now, there's still a lot of manual things. I've identified a few fixes in terms of creating bash scripts that fix things for us, but it still kind of needs work. Grania asks, what are the choices? Yeah, so in terms of web frameworks, I think the choices I have in mind would be, let's see, sounds like a data flow job. That's right. So let's see, I'll address these points. Choices from Grania for web development, off the top of my head, probably things like, just vanilla, web development with no libraries at all. I think Polymer is still a thing. Flutter has a thing for web. Of course, there's Angular and React. There's like and Vue.js are probably the three big web development libraries out there today. So yeah, those are kind of the ones that come to mind. But as folks have other ideas, feel free to throw them in. It probably won't be a super complicated website, is the reality. But we have another interesting question here, and Kafka, right? So Rajan and VMware vSphere, make an interesting point around this kind of sounding like a data flow job, where I'm kind of pushing data in and dealing with it in batches. The reality is that yes, I could solve this with data flow, and in a previous project where it feels like it was a lifetime ago, I tried. And basically my conclusion is that data flow with Python was too difficult for me to understand. I'll say it, right? I really tried. I read through their kind of concept docs around kind of how you need to reconfigure your brain essentially to think about the way data flow processes data. And it's just like, what if I just use cloud functions instead? It'll scale for me and I can use basically any language I want, even like JavaScript node type stuff, which has its own problems when you try to interact with things like the AI platform SDK and API. So now that it supports Python 3.7, I think even 3.8 maybe they're moving to. So maybe that's better. And then then Cloud Run came along, and so it's just like I'm thinking what I can do is create the happy medium between flexibility and kind of super scalability, is to still keep our Docker container type thing, so we can customize libraries, pull things in, but run it in Cloud Run to remove all the GKE management problems. And so that means I can make a Flask Cloud Run container that has multiple endpoints, that my subscriptions can kind of go to this one or go to this one or go to this one, and each one can, using those endpoints, route accordingly, and you'll know like, okay, this is a cloud storage signal for a new image showing up, this is a cloud storage signal for a new model popping up, here's one for kicking off a new batch job, things like that. Rajan says he agrees. For a simple use case, it is a lot of overhead in thinking, and so this is the trade-off, right, of building for the now versus building for the future. Dataflow is really quite good at streaming a ton of data through, and having this streaming happening is really useful. And looking up in the live chat briefly here, VMware vSphere also mentions Kafka, and that's also a good point. Kafka is, I want to say, open source, basically open source-ish, PubSub. Not that it's open source-ish, but it's PubSub-esque. As opposed to Kafka-esque, I suppose. But it's also kind of a publisher-subscriber system that is really useful for doing kind of, actually, let me just switch over to this view, since we're not like doing a lot of stuff in the code at this moment. It's my understanding, and so maybe there'll be some comments here about it, Kafka versus PubSub. While working with GCP, PubSub has proven to be fairly straightforward and easy to work with, and so that's what I'm inclined to kind of just use, because it takes care of the scaling aspect of Kafka. I don't have to configure a Kafka to kind of work across regions and things like that. PubSub is a very powerful solution the way Dataflow is, but it doesn't bring the kind of overhead burdens that Dataflow does. They're different products, they're doing very different things, but conceptually, PubSub hasn't added so much of a burden, for the most part, to me at least, to warrant kind of trying to go for something even simpler, quote unquote. Quote. What I'd be curious about, if people have thoughts on, is the difference in use cases between Cloud Functions and Cloud Run. Especially now I've got Cloud Run kind of working, and I've got the basics of containerization and running this workflow of build and deploy, because you can see here, this is my build and deploy to Cloud Run, two commands, right? I build, I deploy, and what's really nice I'm finding about this is I don't have to put version 11 here. I can just leave this off entirely, and it will just keep doing latest. And I'm still trying to figure out why I can't pull that off with vanilla Kubernetes. But as usual, I'm trading simplicity for raw control, and I just realized I showed you a bunch of stuff on the screen without actually showing it to you on the screen. This stuff, right? It's just gcloud build submit, gcloud run deploy, and that's it. And so that's super handy. And I see we only have a little bit of time left today, and I wanted to call your attention to what we have coming up. We have a lot of really exciting things coming on to the channel. For those of you who have been watching and for the last few weeks, you may have noticed we kind of rebranded things a little bit. It's now called Adventures in the Cloud. It's still the same content. It's still the same people. And on Friday, I'll be sitting down to chat with my colleague Gonzalo. We're actually meeting after this in a couple minutes to talk about kind of what will be the specifics of what we'll be doing, but he'll be talking about 10 ways to use TensorFlow Enterprise. And so TensorFlow Enterprise, if you haven't heard of it, is Google kind of did this wrapper around open source TensorFlow, not to like make it closed source or anything like that, okay, don't misunderstand, but to give it long-term support, similar models to kind of how Linux has their bleeding edge stuff, and they're going to backport patches and things like that. So TensorFlow Enterprise is really useful for kind of organizations that need that kind of reliability and security, especially because they're going to backport patches into previous versions. And so they're supporting TensorFlow 1.15 and 2.1, so they're kind of like continue supporting 1.15. I think all the LTS support is 3 years of time frame, so it's really quite handy there. And so Gonzalo is going to walk us through lots of different ways to access TensorFlow Enterprise and that image and that build. And then coming up next week, guess who is back? Felipe Hoffa. He and I are going to kind of formalize our cadence a little bit. He'll be back on Wednesday next week. Importantly, it's not Friday, it's Wednesday, and we're going to be starting the data show. Okay, and that's going to be every other Wednesday, starting with next Wednesday, and we'll basically be talking about all things data, all things BigQuery, and please let him know what topics you might want to be interested in hearing about, whether it's related to data or just you want us to do something interesting on the air. And so yeah, as always, it is a pleasure to be able to talk with folks and a privilege, and thank you all so much for joining. Before I close it out, let me take a look at one last thing on the live chat that popped up. Gabe says one gotcha around versioning containers is that if you are, for example, deploying jobs to GKE, not containers directly, then latest breaks because it caches aggressively. For deploying jobs to GKE, which is not necessarily a concept that I'm familiar with, as opposed to containers, then using the term latest will break because it caches aggressively. Is that GKE or Cloud Run that caches aggressively? I suspect it's because he's talking about GCR caching, like, oh, this is latest, and then you push another one. It's like, oh, I haven't updated my cache yet. So it's a cache validation problem. Deirdre points out yes, last time we talked about, Felipe had brownies on that he made in his Instant Pot. The plan, the hope, fingers crossed, if we get things sorted out, is that I'll be able to make some Instant Pot brownies on the live stream. And just to be clear, they are Instant Pot brownies. The association of that middle word is tenuous. GKE does. It caches aggressively. Okay, that's good to know. So I guess the one takeaway here from chatting with Gabe here, and we should talk more, Gabe, maybe you can come on the show and we can do this, is get to establish that I have not been doing a lot of extra work for no good reason in kind of explicitly versioning, version 1, version 2, version 3, and having to change it in my HTML, in my deploy.yaml, as well as in my build submit command. So our usual kind of workflow of having to add it to this, but you can't see my screen, but yeah, adding it to the end of the build.submit GCR path. Anyhow, with that said, I'm going to go chat with Gonzalo about what Gonzalo and I are going to chat about on Friday, TensorFlow Enterprise, 10 ways to take advantage of it, use it, and do cool stuff. Thank you all for joining, and I'll see you on Friday.